Hello, 2.5 pre-calculus part 2. Okay, for f of x equal to following, determine any vertical and horizontal asymptote and x-intercept, y-intercept, then graph it. State the domain. Okie dokie, so let's get started here. Vertical asymptote. The first thing I'm going to tackle will be vertical asymptote. Denominator, let denominator equal to 0. X squared minus 4, let that equal to 0. Solve for x. You can factor this, or I can just solve directly. X squared equal to 4. X equal to, I took a square root both sides. Be very careful not to forget plus minus here. Many students miss minus, then I'm going to lose you. Whenever you take your square root both sides, you have to put plus minus. Square root of 4 is 2. So I got vertical asymptote 2 of them. Okay, x equal to plus 2, x equal to minus 2. And this is a fancy way of writing two of them at the same time. So x equal to plus minus 2 is my vertical asymptote. You can knock off domain right away. X cannot equal to whatever you got. X cannot equal to plus minus 2 either. That's a domain. Okay, horizontal asymptote. Horizontal asymptote, hopefully you still remember these categories. Please watch my first video, part 1, if you did not watch that. Horizontal asymptote, look at the highest power of x on numerator denominator. This is the first power, this is second power. We have a higher power on denominator. Then what did I say? Y equal to 0 is a horizontal asymptote. So y equal to 0 is your horizontal asymptote. And I'll be careful. If I ask you range, you might want to say y is not equal to 0, which is true, but there might be more. So usually for the range, you will have to graph it and take a look at it. We did not ask you for the range. So let's move on. X-intercept. X-intercept, you plug it in y. F of x is y. So y equal to x plus 1 over x squared minus 4. How do you get x-intercept? Plug it in y is 0. Okay, so plug it in y is 0. Solve x. We have to get rid of this x on denominator. How? Multiply by denominator both sides. So multiply by x squared minus 4 both sides, because you're going to cancel this out. 0 times whatever becomes 0. So 0 equal to x plus 1. Solve for x. X equal to minus 1. I don't know if you noticed it. Denominator, whenever you find the x-intercept, denominator always disappears because 0 times denominator is always 0. So you get end of it, whatever numerator equal to 0. And that's what this says. X-intercept, a of x becomes 0. A of x is numerator expression. So if you caught that, you can save some steps here. Whenever I ask x-intercept, whatever numerator, just let that equal to 0. Whatever numerator, just let that equal to 0, solve x. That might be a little faster than going over that. So we got x-intercept, which is minus 1, 0. Time to calculate y-intercept. Okay, y-intercept is what? Plug it in x as 0. So y equal to 0 plus 1, 0 squared prime minus 4. So y equal to 1 over minus 4. That is your y-intercept. 0, minus 1/4. Okay? Then what? Graph. Okay, this one will be a little interesting to graph. Here. So let me show that to you. I got y-axis here, x-axis here. First thing you want to do is put the vertical asymptote. Vertical asymptote, we had a 2. X equal to 2, dot, 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 dot. X equal to minus 2, dot, 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 dot. Dashed line. Horizontal asymptote is y equal to 0. Y equal to 0, you got horizontal asymptote right here. Why did I say this is a little interesting? Because we have now 1, 2, 3. 1, 2, 3 intervals to deal with. Okay? Plot the points we already have. Minus 1, comma 0, we got x-intercept. Minus 1, comma 0, we got 1 point here. That's good. 0, comma minus 1 first. So 0, comma minus 1 first. Somewhere over here. Okay. We got 2 points here. So we got something going on here. Why don't you get, so here is the middle section scenario. When you have a horizontal asymptote, vertical asymptote like that, you can have many different scenarios here. You could have something like this. You could have something like that. You could have something like this. You could have something like this. Well, when I look at this orientation of the location of points, I don't think that's going to happen because you have to kind of go this way. So I don't think that's going to happen. So we are still open for maybe that's going to be a little difficult. But so you have many different scenarios here. So you might say, well, how am I supposed to know? You have to just get the points, plot it, get the points, plot it. That's the only way here. So you will have to choose some point on the right. So I'll probably plug in x equal to 1 and see what's going on here. So you plug in x equal to 1 to the equation. So 1, so let's go to x equal to 1, plug in x equal to 1. So y equal to 1 plus 1, 1 square minus 4. That's what? 2 over minus 3. So you got minus 2/3. That's like minus 0.66, something like 667. So x equal to 1, you got minus 0.6 or something like that. Okay, so I am more forward like going like this. So to get the better graph, you will need to plug it in even that small, like 1.5. You need to plug in like 1.5 because I want to know what's going on here. So that I think I'm going to use a calculator. So I'm going to plug in x equal to 1.5. So plug it in y equal to 1.5 plus 1 over 1.5 squared minus 4. So I'm not doing that by hand. Okay, so if you do calculate this, I got minus 1.429. So 1.5, I got minus 1.4, I would say. Then you got what? You got 1.5, you got minus 1.4, that's even. So that's pretty clear to me. It's kind of going down like that. So what does that mean? If you get like 1.9, you will probably get a lot lower value. Okay, I just want to make sure is it turning around or is it going up? So I'll probably need to get one more point like minus 1.5. So what if I plug in x value as minus 1.5? What would be the value? I get minus 0.113. Ah, so you get x equal to minus 1.5, you get actually minus value. That's interesting. So I thought maybe it was going up. So maybe I can do even closer, minus 1.9, then minus 1.9. Then I wonder, I got 2.3. Okay. What was the minus 1.5? Oh, okay, so I made a mistake with my calculator. Minus 1.5, it wasn't minus 0.13, so it was a positive value. Okay, that makes more sense. So when I plug in minus 1.5, it was 0.3, 0.28, 0.29. So I'll say 0.3. Okay, that makes better sense here. So when I got minus 1.5, I got some positive value here. And I got minus 1.9, then it's shooting up. Okay, so that was a little tricky, but now I got the idea. So you got graph going like this. So you might say, that's a lot of work. Yeah, you're right. I did what? 1, 2, 3, 4, 5, 6 points on this. So if you have to graph this by hand, yes, it will take some time, especially without calculator. That's gonna be some time. You would probably need a calculator, not graphing calculator, because graphing calculator you can just graph it. So usually when I do this with my students, I let them use a calculator which doesn't have a graphing feature. So they can still calculate this decimal and all that using calculator, but my intention is graph this without graphing calculator. So you might have to do a bunch of points here to get good grasp of what's going on inside. Okay? Okay, so middle is tough, but right-hand side, left-hand side should be relatively simpler. Why? Because if you get point on the top, you will have graph something like this. If you have a point on the bottom, you will have graph like that. So this side shouldn't be that bad. So I'm gonna plug it in 1 point on right-hand side of this vertical asymptote. So x equal to 1, 2, 3. 3 is good. 4, 5, 6, any value is good. So I'll plug in x value as a 3. So I'll plug in x value as a 3 here. So x equal to 3, which is what? Y equal to 3 plus 1, 3 squared minus 4. That, I think I can do that by. So 9 minus 4 is what? 5. That's like decimal. 0 point something. 0 0.8. I think 0 0.8. Yes. So you got 0 0.8. So 3 comma 0 0.8 is like this. That's all I need. 1 point. Because that tells me my graph will be something like this. I'm not going to have graph down here because I have a point here. You want to do similar thing on the left hand side. So you will plug in x value as like minus 3. Plug it in minus 3 for value of x. So that will be what? X equal to minus 3. So y equal to minus 3 plus 1 all over minus 3 squared minus 4. So you got minus 2 over 5. So that's like minus 0.4. minus 0.4. So we got minus 3, minus 0.4 is somewhere over here. That's all I need. I have some graph action going on the bottom part. Okay, so that's the graph without graphing calculator. So if you look at all that, yes, that will be the correct graph. So whole point of this is, can you sketch that without using graphing calculator? Okay, of course, if you have graphing calculator, and if I let you use graphing calculator, you can just type it into the graphing calculator. You can just type it in and you can sketch it. But mostly, I ask this kind of question without letting you use graphing calculator. So let me see if I can show you. Here. So you could have graphed y equal to, be careful when you type in the equation though. You have to parenthesize the numerator, you have to parenthesize the denominator, otherwise your graph will be wrong. So parenthesize x plus 1 divided by parenthesis x squared minus 4 parenthesis. Okay, so if you do graph it, you get nice graph like that. It graphs it all whole entire shape for you. But do you remember, the point here is, can you do that without graphing calculator? Can you graph it by hand? That's the whole point. Okay,